All right, let's talk about significant figures. You have learned this in probably every science class you've taken at Xavier. So I don't really want to spend a lot of time on it, but you are held responsible for it. You do not want to get to college and not know your significant figures. You don't want to embarrass yourself by presenting something with the incorrect number of significant figures. For starters, significance is all about measured data. If I were to tell you that something lasted 3.5 seconds, well, 3.5, that's two significant figures, and then you doubled it, so you multiplied it by 2. So 2 times 3.5 seconds. That has two significant figures. You might think that the 2, where did the 2 come from? I just said you doubled the time. Or, you know, if you tripled it, that would have been a 3. If you quadrupled it, that would have been a 4. You doubled the time, so where's that 2 come from? It's just because I doubled it. You might think that that's only one significant digit. No. No, 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 no. That's not a measured value. It's not a measured value. It has nothing to do with significance. Significant figures is only about the measured values. You measured this as 3.5 seconds. You didn't measure it as 3.51 seconds, because that would have been 3 significant figures. You didn't measure it as 3.507 seconds or whatever. All right, you only measured it to the nearest tenth. All right, this is 2 significant digits. That's where significance comes in. So if you were to take something like that and multiply it out and you get 7, that would be wrong. Because that's only written to one significant digit. When you multiply or divide, your answer has the same number of significant figures as the least number of your input. This has 2, so this would have 2. All right. Again, that doesn't play into it because I just doubled something. Let's just say, by the way, that would be 7 seconds. Don't forget your units. Let's say that you are calculating a velocity and you travel 100 meters in 25.0 seconds. So you calculate that out, and of course 100 divided by 25 is 4 meters per second. Now the question is it 4 or is it 4.0 or is it 4.00? Well, this has 3 significant digits. This only has 1. This isn't 100. We don't know. If this were 100, there's a couple ways. If you wanted to make all 3 of these significant, you could put a line over that 0. Or sometimes you'll see this, they'll put a dot right there without another digit to the right of it, because that would make it 4 significant digits. But I didn't do that. Right? This is 1 significant digit. That means that whatever I was measuring the distance with only measured to the nearest 10. All right. So it could have been 104, but I didn't have a good enough measuring instrument to know that. It could have been 96 meters, but I didn't know. All I could do is estimate it to 100 meters, and so this is good to 1 significant digit. So that's correct. That's the correct answer. What if I had something like this? What if I had been traveling 100 meters and it took 11.382 seconds to go 100 meters. And so I calculate this out, and I take 100 on my calculator. Oopsies, I take 100, and I keep blowing it. 100 divided by, there I hit the right key, divided by 11.382, and I get 8.78. I get 8.785800. Well, what's the correct answer? Paying attention to significance. My answer can only have as much precision as my least precise input, which in this case is the 100. That's good to one significant digit, remember? So don't you put, isn't it more precise, Mr. Wyman, if you write down all that stuff? No, because all this stuff is meaningless, because we don't know if that's 96, 95.5, 95.17875, 104.6. I don't know. All I know is that's roughly 100. So the fact that all this precision is meaningless, because we don't really know this any greater than to that nearest number. So this is valid to that, 9 meters per second. That really bugs people, but that's correct, okay? If I had given you something like, 102 meters, let's even go further, 102.6. So that's 1, 2, 3, 4 significant digits. This is 1, 2, 3, 4, 5, okay? And let me get out my handy dandy calculator again. So 102.6 divided by 8.7858. Night you do blah blah blah. One blew it. 1.2. God, I can't think. 102.6 divided by 11.382. And I get 9.01. Okay. So 9.0143, yada, yada, yada. That's from the previous problem. Well, where do I round it? That has 4 significant figures, and this has 1, 2, 3, 4, 5 significant figures. Remember, this is meters per second. So we round it to the input with the least number, so that's 4. So 1, 2, 3, 4. Now I round down so it stays as 4 because that's a 2. If this had been like a 5 or a 6, I would have rounded that number up. All right. So that's my answer. One other thing on this, I don't want to beat this horse too much. But when you are adding and subtracting have a different rule. So if I were to add 26.7 to 1.36, no, let's add 126.7 to 1.31. So that would give me 100. I don't count the number of significant figures. This top one has 4. 1, 2, 3, 4. This one only has 3. So that'd be 1, 2. That'd be, whoopsies, I should have gone this way. So then 8. But your answer can only be precise. This is precision. It can only be as precise as your least precise input. My least precise input is this top one because it only measured to the nearest 10th, whereas opposed to this one which measured to the nearest 100th. I don't know if this is 126.72 or 126.69 because it didn't measure out to that extra place. It only measured to the nearest 10th, and so this is a rounded number, rounded from wherever that came from. Therefore, it can only be as precise as the least precise input data. That's the rule for addition or subtraction. Again, don't count the number of significant digits. Look for the degree of precision to the right. All right, whichever one's the least precise, stop there. Again, in multiplication and division, count up the number of significant figures. If I multiply these, my answer would be to 3 because that's got 3 and that's got 4. But I wasn't multiplying; I was adding. Time to stop. Whoopsies.